The other algorithm that you need to know to find the minimum spanning tree of a network is Prim's algorithm. Now, Prim's algorithm is quite different to Kruskal's in the way that it's executed, but the result is the same. It gives you the minimum spanning tree of the network. It is not heuristic, it is guaranteed to give you the optimal solution, or one of the optimal solutions if there are multiple. The difference with Prim's is that rather than keep looking at the whole network and keep choosing the shortest arc, what you're going to do is you're going to start at a node and your tree grows. So here's the algorithm. You're going to choose a starting node. In an examination setting, it's usually given to you. You're going to move to the closest node to your tree and then stop when you have n-1 arcs. So rather than having kind of arcs picked up here and there across the network, like you do with Kruskal's, instead you're going to have a tree that grows from a point. Okay, you always have exactly one tree. It is never disjointed. Okay, so let's just start at A. It doesn't matter where you start, the result will be the same. So I'm just going to highlight where I'm going to start. So I'm going to start at A. And again, I'm just going to make a list of the order in which I choose the arcs, so that it's evidence that I am following the algorithm requested of me. So the first arc I'm going to choose is 3. So I've got a choice of 3 or 6. So I'm just going to scribble that one out, and I'm going to put AB is 3. And then I look at all of my nodes that are connected to my tree, not just B. I've got 7, 4, 2, and 10. I also look back at A, which is 6. And of those, in this case, 5 numbers, I choose the smallest, which is this one here. All right, so BE gets chosen next, and it's a 2. Notice there's not going to be any rejections for this algorithm. Okay, you reject arcs in Kruskal's, but you don't reject arcs in Prim's. Okay, then we've got 3 nodes to look at, because there's 3 nodes that are part of my tree, okay, A, B, and E, and I choose the smallest arc that is connected to one of those. So we've got 6, 7, 4, 9, 3, 8, 5, 9, or 10. So the smallest of those is 3. So that's one that gets chosen next. So that's DE, which is 3. Repeat the process again. So choosing this 4, I'm not going to choose that one because that's not joining a new node. Okay, move to the closest node to your tree. Both of those are part of my tree, so this doesn't get selected. It's not even considered. So I've got a choice of introducing C, and I can do that by 6, 7, 9, or 7, or I can introduce one of these 3. And I'm actually going to choose this one here. That's the 5 is the smallest number, but there are 2 choices I could have made. I could have chosen DH, but I'm choosing EG this time. In my previous video, using Kruskal's, I chose DH. And then move down here. So GH is 1, and then I'll be choosing this one over here. Notice that every time I'm choosing an arc, I'm also ringing a node, because I'm introducing a new node to my tree. Oops, that's a 6, not G. And then finally this one up here. It's got to be that one. So that's FG, which is 8. Okay, so my minimum spanning tree are all of my arcs that are selected. Sometimes you'll be asked to draw out a copy of that, in which case you would draw out the green arcs, just those 7, and it'll ask you for the total weighting. So that's 5, 8, 14, 15, 21, 29, 5, 6, 7, 8, 13, 14, 20, 28. That's good. I got 28 last time, so that's why I double counted. Okay, there we go. Right, let's show you Prim's on another network. So this time I'm going to start at node A. Starting at node A again, different network. So I'm going to choose the closest arc to A, closest node to A, which is C. So AC is a length of 7, and then I'm going to be choosing the 4. So that's CE is a length of 4, and then the closest one I can choose either EF or ED, which is EF, which is 3. Then because I've introduced F, that one now becomes the closest. So FG is 2. And then I've just introduced G, so therefore that's now the closest. So that's GH is 1. And then this one here, DH is 2. And then one of the 5, doesn't matter which 5, I've got a choice I can make. So let's go that one there. BC is 5. Chosen 7 arcs, 1, 2, 3, 4, 5, 6, 7, which is good because I've got 8 nodes, 1, 2, 3, 4, 5, 6, 7, 8. So it should always be 1 less arc than the number of nodes. Okay, 11, 14, 15, 16, 17, 18, 19, 24. That is the minimum spanning tree of this network, or a minimum spanning tree. There's a couple of different options actually for this one. I could have chosen that 5 instead of that one, and I could have chosen that 3 instead of that one. So there are actually 4 different minimum spanning trees for this network. All of them have a total weighting of 24. All right, thank you very much for watching. Next video, we're going to have a look at how we go about finding a minimum spanning tree when you're given a table instead of being given the network.